So yesterday, we found the area of rectangles, paper rectangles, using our base 10 units, right?
Mm-hmm.
We found the area.
Yeah.
I want you to think for a minute about what area is now and what it means. Think privately. And I want you to turn to your elbow partner and tell him what you think.
It's like the square. Yeah, it's no, not around. Like I think how many are inside that shape? Inside of the shape.
It's flat.
I think it's the inside of the shape.
Yeah, it's flat squares that are inside the shape.
Well, not really any shape, but it just has to be a
Okay, we're
two-dimensional
quiet
shape.
in 3, 2, 1. Thank you. Let's have a few of you share. Nate, what did you tell your partner?
It's the area inside of the shape.
The area inside the shape. Thank you. Brayden, what would you like to add to that?
The area, if you made a circle with your hand like this, it would be the inside of the circle.
Okay, and Ivan, what do you think?
Area is the size of is basically the size of a two-dimensional figure.
Okay, thanks. You guys had all really good comments. Now today, we're going to use different square units. Yesterday we used these, base 10. Today we're using these. We're going to find the area of different objects inside the classroom, different rectangular surfaces. So, I want you to think for a minute. Make an estimate to yourself. If I have to find the area of this paper, and I'm using these square units, how many do you think I would take? Think to yourself. Okay, share with your elbow partner. Okay, quiet in 3, 2, 1. Maddie, what did you and your partner share?
We said 8.
8? Sounds like a good number. Kendall, what do you think?
Well, my partner said 6, but I think 12.
You have some good guesses. Let's find out. Okay, so think about the number you've had. Now I can't overlap the squares, can I?
The paper.
Okay, can you see what I've done so far then?
Yes.
So how many so far? Raise your hand with the number of fingers that I have up there. Okay. Keep going. Remember, this is an approximate measurement. Now I'm going to flip this board over so that you can see the white paper a little more clearly. Raise your hand with the number of squares it took. Show you with your fingers. Okay. Is that exact?
No.
Thumbs up if you think it's exact. Why isn't it exact? Juan. Is it exactly 6? Can you tell me why?
Most of the square doesn't really cover it.
It doesn't quite cover it. All right.
Unless you move it around.
So what do you mean, Nick, unless I move it around?
Really kind of getting perfect.
Okay, so does that help? Did we cover the entire piece of paper?
No, this is like that.
No, that's why we call it an approximate measurement, right? It's not exact.
Yeah, you have exact measurement. You have to do either fractions or join.
We would, wouldn't we? We'd have to add in fractions.
Yeah, I think it's about 6 because this is
Okay, so about 6, little more than 6, right? Okay, so today, thanks Nick for your help. Today we're going to work with partners And you're going to use these squares, the same size, either orange or black, and you're going to measure different surfaces within this classroom. I need my 2 paper passers. I want you to look at it and think about what you notice, about some of the things you might have to do. Think about any questions you might have about this. Does any of it look familiar? Think to yourself. Think privately. Share one thing you notice with your elbow partner.
We do this like every month. We do this in math. We do this in measurement.
And this is large
Sometimes we get our homework.
and the different and then area. They're all area
You were quick.
instead of inches and centimeters. And they're all flat.
And they're all right. They're all right.
It does, but I think it means more like this.
Yeah, they are.
What do you think? Which would be the easiest to measure?
Because if they're a circle.
Okay, we're quiet in 3, 2, 1. Mackenzie, what do you notice? One thing you notice about this paper? Anything look familiar? We haven't done anything like this before? Measuring. So this is about measurement, maybe? Okay. Kenna, what do you think?
Well, we've done it over first, and this is one of the games we play.
It is like one of the games we play, right? In workplaces, right? So let's look at the first object we have to measure. And again, I want you to think about what we're measuring. Mackenzie said we're measuring, but what are we measuring? What are we measuring, Kendall? Something in the class, but what part of measurement? We're measuring the height. Can you talk louder so that Nate over there can hear you?
Area.
Area. Did you hear that, Abby? What are we measuring?
Area.
Area. Okay, so let's locate our first object. Any questions? Anything you're really wondering about or you're confused about? Mackenzie.
Do we have to do it like this with the line?
What do you think? We're measuring rectangular surfaces, so what do you think you would be measuring on your desk? What? So go to your desk and show me what you think you would measure on your desk.
Right here, and down on the
Okay, so think about using these to measure it. What do you think now? If you're going to lay these on top of the surface, what do you think? Ask your team real quick.
I think
Top of the desk. I think that makes more sense, don't you?
Yeah, because it's like
We could do the side of the desk, but I think that one might be kind of difficult. So we'll do the top first, since we're just beginning with area. Hannah.
I'm gonna have 2 questions. Do we have to do it in the same exact order?
You do not. You can do it in the order that you and your partner would like to do it in.
And are we gonna be measuring them ourselves?
Say that last part again.
Are we gonna be measuring them ourselves? Like just the partners?
You and your partner will. Yes. Caleb.
Are we gonna use our elbow partners or corner partners?
We're going to use your corner partners this time. Okay. We talked this morning with elbows, now we're going to use corner partners. Not today. We'll try that another day. Okay, so do we have every question covered here? I think so.
Yeah, it's 4. I know it's 4. Dude, you gotta write down your estimate. Okay. It's 4, see? There's a half equals 4. And then a whole. Yeah. This is 5, guys. It's 5. Our book is 5. Whatever. Yeah, half and half. That would go all the way to there. And then if you turned it around, it's exactly half. Yeah, so it's obviously 5.
Get the next group going.
Wouldn't this be like 4.5? No, that's 5. 5.5 is this.
What do you think?
5?
What do you think?
I think 4.5 because there's 1.5 here.
Okay, you should write down what you think. Because remember, it's an approximate measurement. It's not exact.
Is that like 6.5?
What do you think?
It looks like 6.5.
You and your partner talk about it and discuss it and come up with the best answer.
Is that 6 or is that 6.5? Yeah, that's 6.
Is that a good idea?
Yeah.
Let's try that again, okay?
Oh,
Oh, no. Let's try it first and see.
do the whole thing?
The top, yes. The rectangular surface of the top.
It's probably not going to be all the way.
Yeah. Yeah.
It's not going to be exactly, but it's going to be pretty good.
Oh, now what did you find?
6.5.
Where's the half?
It's not a half. So like 6, 7. What did you get? No, what is a lot? Yeah.
What do you think? Definitely these 4, right?
I'd say 20/40 of what the chair, because I think 9 for the chair. Really 8, right? For just the part that you sit on, I'd say 12. I'd say 9 because I think 3, 3, 3. So 9 equals 9. I'm just guessing. Or 25.5. 26, 26.5, 27, 27.5, 28. Wow, we were way off. I was at 18. That was a good guess. What was it? 28 square units. I can do this. I think 28. I think the difference is 3. What? I think I would do about actually the difference is 4. On mine it is. Mine is 3. Yours 4. Oh yeah, mine is 4 and yours is 6.
If I were looking at this, what label do you think I would want to see? What would be a good label to use for this? What did you use to measure it? So how would you label it?
Five, 10, 15, 20, 25, 35. Well, when she just 7 times 5, she just answered 5. You're just
7.5, 8, 8.5, 9, 9.5, 10.
Okay, so what I want you to do is trade papers. Worry about yourself. So you guys decide between yourselves. What was the question?
I think it's way more than 12 pounds. There, Nick.
So what do you think now?
Looks like 4.
4.5?
It looks like these are one because it looks like half and half.
Tell your partner.
Looks like half and half of these, so I think it's one. One. It's one square because this is half and half. Yeah.
Could you fold one of these and show me what you mean, Hannah? Because I'm still a little confused.
Yeah, wait. Wait.
We're just experimenting.
Yeah, 18.
We're gonna need them.
You will.
Oh, there's one. Can I go to the bookshelf?
Yes.
See, it's half.
And if you put two halves together, you have
A square.
a whole, right? So what is the... Nice. Okay, what did you come up with?
No, it's 39 square units. Yeah, we came up with 39 square units, and my prediction was 30, so I was just 9 away.
Okay, can you just show me how you came up with 39? Like, go down one side and show me how many.
So there was a half right here. So there was 3 rows, and then there was a half not filled in. So she helped us do the time.
What did you do with those halves?
Like right there, the 2, we had 2 squares like that, and then there are 2 more squares all the way down. This what was in
Just a
half.
second.
So we had
You were doing a good job.
like right here, and then two squares. Because one of these, like it was right there, was a half,
Okay.
and then another would be another half, so that would equal 1.
Oh, could you fold one of these and show me what that means? Because I'm still a little confused.
You see, like
Just a minute
it
now.
would be like it'd be like
I asked him
this.
to.
It'd be like this, that much, on all the way down to there, and then half, and then there'd be another one right there, half.
Oh, so if I put these two halves together,
Yeah. That's how we got up with 1.
that makes sense. Okay, so you came up with 39.
Yeah. Mr. Milf.
And then this is 1, 2, 3, 4, 5. 18 in that box. This is 1, 2, 3, 4, 5, 6, 7. And this is 5. So 5 plus 5 equals 10. And 7 plus 7 equals 14. So that equals 24. So 24. 24? Uh-huh. The area. So 1, 2, 3, 4, 6, 7. 7 plus 3, 7, 3. So 3 plus 3 equals 6. And then, wait. 7 plus 7 equals 14. So 6 plus 14 equals, so 6, 4, it equals 20. So 20. Alright, this one is 1, 2, 3, so 3. Then 1, 2, 3. 1. So 6 plus 6 equals 12. So 6 plus 12. Okay, so that's what 6 equals. 6 plus 6 equals 12. So it equals 18.
Perfect too, Ivan.
Okay.
What did you notice? What did you learn? Okay.
That square units were harder than inches and centimeters because like you have to use these papers but on inches and centimeters you have to use a ruler, so it makes it easier.
Write that down. That's a good I noticed.